Assalamualaikum. Today I would like to present our assignment group for AC module. For the objective, there have 4 objectives that we got from this assignment. The first one is to determine the shape and type of the waveform that display in the oscilloscope. Second, to determine the inductance and capacitance from the circuit. Third, to determine the phase angle for current and voltage in RLC circuit and calculate the phase difference of the waveform. Lastly, to compare the calculation result and the simulation of the circuit.
Okay, for the simulation, as we can see in the circuit, the value of XC and XL is given, which is 5 ohm for XL and 10 ohm for XC. But to do the simulation on Proteus, we can't use the value of XL and XC. So we need to calculate the value of L and C for the inductor and capacitor. So from the formula of XL, which is XL equals to 2 pi FL, we rearrange to L equals to XL over 2 pi F, and we insert the value which is 5 ohm for XL and 50 Hertz for the frequency, and then we got 0.0159 Henry. While for capacitance C, we use the formula at C equals to 1 over 2 pi FC, and we rearrange equals to C equals to 1 over 2 pi Fxc, and we insert the value given, which is 10 ohm for the Xc and 50 Hertz for the frequency, and we get 318.31 microfarad. Now we can build the circuit on Proteus. To build the circuit, we need a V sign and 2 resistors, 1 and 2, and there is inductor between them, and also a capacitor here. We do not forget to take the ground here. Now we can connect the circuit. Connect the circuit. After we connect the circuit, we can add the probe. The probe we will use is voltage probe and current probe to show the waveform on the graph, that we can calculate the phase angle. Okay, now we insert the value for the component. Okay, after we done with that, we need to add the analog graph here, and we add trace for the current and also for the voltage. now we edit the graph so that we can see the waveform clearly. So basically, roughly from the graph, we could see that the graph of current is leading the voltage. So I pass to AMIRA for the next part. Thank you.
Okay, for this question, we need to calculate the phase angle between I and B. First of all, we need to find out the information given from the circuit, which is for V, we can know it is 50 volts and the angle is 0 degree because the question not give us any angle to use. And for SL, we can know from L1 which is 5J. And for XC, we can know from C1 which is negative 10J. And for R total, we can know by adding R1 and R2, which is 10 plus 5 equal to 15 ohm. And then we move to the find the impedance Z. To find the impedance Z, we can use the formula R total plus XL plus XC. Then we just enter the value that we get just now. 15 plus 5J plus negative 10J. Then we get the answer 15 minus 5J ohm. And then we move to find the magnitude and angle for Z. To find the magnitude, we can use the formula Z is equal to square root x squared plus y squared. For x, it is 15 from this answer. And for y, we can know it is negative 5. Then we just enter the value. Z is equal to square root 15 squared plus negative 5 squared. Then we get the answer 15.81. And for the angle, we can use the formula theta is equal to tan negative 1 multiplied by y over x. Then we just enter the value tan negative 1 multiplied by negative 5 over 15. Then we get the answer theta is equal to negative 18.43 degrees. Then we just write down the answer for Z. Then we find the I. For I, we can use the formula I is equal to V over Z. For V, we already know just now 15 and the angle is 0 degree. And for Z, it is 15.81 and the angle is negative 18.43 degrees. Then we get the answer 3.163 and the angle is 18.43 degrees ampere. Then we just write down all the answer for I and V. For I, 3.136 and the angle is 18.43 degrees ampere, and for the V is 50 and the angle is 0 degree volt.
We will continue with our presentation. For discussion, in this assignment, practice is used to construct a RCI circuit based on figure 16. Based on this figure. Since the circuit has only SL and XC values, so the values of the inductor L and capacitor C can be calculated using the formula SL equal to omega multiplied by L and XC equal to 1 over omega multiplied by C, which is omega is 2 pi f. F is frequency. Based on this circuit, V sign has been set at a value of 50 volt for amplitude and 50 Hz for frequency. The formula I equal to V over R, where R equal to Z, is used to obtain the current value. Analog analysis is used to evaluate and display current and voltage graph. Based on the simulation graph, the formula used to obtain the value of the angle between current and voltage is the time difference between current and voltage divided by the total time of one complete cycle of the wave multiplied by 360 degrees. Thus, The voltage current graph shows that current is leading the voltage by 18.435 degrees. D is because the capacitive reactance is larger than inductive reactance and make this circuit as a capacitive circuit. The percentage difference between the measured and calculated value for this current and phase angle was 0.0727% and 2.36% respectively. Now we continue with the conclusion. In conclusion, by using C and SL formula, we can determine the inductance and capacitance. Besides that, we can determine the phase angle using the current and voltage waveform. Lastly, in this assignment, phase angle that we got from calculation is 18.435 degrees and from the simulation is 18 degrees.